Right, so this is our last section for chapter 3, and then we'll be officially halfway through all of our material in terms of chapters anyway, so we have 6 chapters. So this one we're talking about the slope-intercept form of a line, which we took a look at a little bit last time. That's the y equals mx plus b form. And we're going to use that to graph some equations and then write equations of lines using that form. So just to recall what we looked at last time, the slope-intercept form of a line, I'll just call it slope-intercept, is that equation y equals mx plus b. When you're looking at the equation of a line, you're always going to have the y and the x unless you have one of those special cases where it's just one or the other. And then m and b are going to be replaced by numbers. So m is the slope, and b is our y-intercept. And it's important to remember that it's the y-intercept, not the x, so that when we start graphing these, you're always going to be plotting the y-intercept on the y-axis, not on the x-axis. And that y-intercept is going to be of the form 0, b, 0, whatever that number is, because that y-intercept is still a point on the graph. And so yeah, sometimes the question is going to be looking for the specific form. So if you just type in the number, whatever it is, let's say it's 2, you might get it wrong because they might want the point 0, 2. So just be careful on the MyMathLab formatting for the answers on the homework. Let's go ahead and look at our first set of examples. And for this set of examples, we're just identifying the slope and y-intercept. And these ones are going to be pretty nice. Sometimes you'll have to rewrite the equation in slope-intercept form first, but for the most part, they should be pretty nice. So number 1 here, we're given the equation y equals 2x minus 6. And so this one's already in y equals mx plus b form. So all we're looking for is the slope, which is this 2 right here. So I'm going to say our slope equals 2. And our y-intercept, which is a point, is b. Always include the sign. So our y-intercept is -6, but we want to write it as the point 0, -6. And this is all we're doing for these. This is just kind of setting us up to start graphing these. Let's try another one. Y equals -x/3 plus 7/3. So again, we're looking for our slope and our y-intercept. So our slope for this one isn't as obvious. We have a -x/3. And so if you remember, if you don't see a number here, we always have a 1. And so instead of writing this as -1x/3, we're going to take our coefficient out in front. So -1/3x. And so our slope is -1/3. And our y-intercept, still using this last number here, is 7/3. So it's the point 0, 7/3. All right, and one last one. Number 3, y equals -x. For this one, our slope, we can still see, well, kind of, we want to write in a 1 here, so our slope is -1, but our y-intercept, we don't have that plus b at the end. We don't have anything right here. So if we don't have anything, we can't put a 1 because +1 would actually be written there. +0 doesn't change it. So we can go ahead and put in 0 as our y-intercept. And so remember, we always have 0 for x, just like in these other 2 y-intercepts over here. And our y-intercept is also 0. So this means that our y-intercept is the origin. It's the point 0, 0. All right, now that was just to set us up for graphing equations. So let's go ahead and practice this a little bit more as we start graphing. So graphing using slope-intercept form. So if we want to graph using slope-intercept form, a couple of steps that we want to take. The first step is to put the equation into y equals mx plus b form. If it's not already, it might be given to you in that form. Second step is to go ahead and plot the y-intercept. So remember, this is always going to be a point on the y-axis. Once you have that done, we're just going to plot another point using slope. So y-intercept, plot another point using slope, and you should have your line, and you can draw your line through those 2 points. So now let's go ahead and look at some examples. And again, if you have graph paper, perfect, I would go ahead and use it. I don't, so these might be a little bit messier than yours. All right, so we want to graph using slope and the y-intercept. Number one, we're given the equation y equals 2x minus 1. So we're going to start off with a nice one. It's already in the correct form. So now we want to figure out our slope and our y-intercept. So our slope, or m, is 2. And then our y-intercept is -1, so 0, -1. So the only thing I'm going to add here is that our slope is 2. In order to graph using the slope, we need the rise and the run. Depends, might be in a different direction than this. So I'm always going to change this to 2 over 1, always have a fraction. And so this 2 over 1, since this is our rise, this is saying go up 2 since it's positive. And our run is on the bottom, it's our horizontal change, so we're going to go to the right 2. Really pay attention, sorry, not 2, right 1. Really pay attention to those signs. If either one of those was negative, a negative on top would mean you go down 2, a negative on the bottom would mean you go left 1. You shouldn't really have the case where you have a negative on both. So either have a negative on the top or on the bottom, and we'll see one where you can kind of see why it doesn't matter where the negative goes as long as you have it on one or the other, but not both. All right, let me go ahead and set up our axes. Try to do these as straight as possible. And our horizontal axis. And we'll go ahead and put in some tick marks. So if you notice, our y-intercept is -1, so we're not gonna go down too far on the y-axis, and our slope is only 2, so we're only moving 2 in our vertical direction, 1 in the right. So I'm not gonna go out too far. I'll go out to 4 on all 4 of these axes. So 4 to the right, -4 left, -4 down, 4 up. And so we're going to start at our y-intercept. So our y-intercept is 0, -1. So we start down at -1 on the y-axis. And then our slope is telling us to go up 2 to the right 1. So we're going to go up from our y-intercept, go up 1, 2 to the right 1. Make sure you count the origin as one of your movements because it is technically a tick mark. We just don't really put tick marks there. So you can go ahead and just do 2 points, but now that it's super easy to plot points, you're not plugging in numbers, you can always do multiples. So I'd go up 1, 2 over 1 again. Mine's going to be a little bit off just because these tick marks weren't all even, but we can go ahead and draw our line through those 3 points. Make sure you have the arrows on the ends, and we have our line. Let's go ahead and try another one. Number 2, we're given the equation 3x minus 4y equals 8. So now, just looking at this one, we don't know what the slope and the y-intercept are because it's not in y equals mx plus b form. So first thing we want to do is get this y by itself. So I'm going to go ahead and move this 3x over. So subtract 3x. Cancel those out. We're left with negative 4y. And remember, to put this in mx plus b form, I'm going to put the x term first. So negative 3x plus 8 because it's positive. And now divide every single term by negative 4. And so we get y equals negative over negative is a positive. 3 over 4 can't be reduced, so 3/4 x. 8 divided by negative 4 is negative 2. And so now our slope is 3/4. So the rise is 3, so up 3, right 4. They're both positive. And our y-intercept, I don't know why I wrote intercept twice, but I did. Our y-intercept is 0, negative 2. Okay, so let's go ahead and graph this one. I'll do it down here so I have room for some more. Okay, and the horizontal axis. And now, put in some tick marks. Again, our y-intercept is negative 2, so we're only going down 2 on the y-axis. Our slope is 3/4 though, so we're going to be moving up 3 and right 4, so we want to make sure we go at least out to the right 4. I'll just go to 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And let me label those. So our y-intercept is negative 2, so we're starting down at negative 2 on the y-axis. And our slope tells us to go up 3 to the right 4 from our y-intercept. So up 1, 2, 3 to the right 1, 2, 3, 4. And because it's going to get pretty big, I'm going to leave it just as these 2 points. If you want to plot another point, you can. I'm going to take my line, put it through those 2 points, and there we have our line. All right, these next few are a little different. We're not given equations. For this one, we're told to graph the line passing through. We're given the point 2, negative 3 with a slope of negative 1/3. So now this one's pretty nice. It's actually a little bit nicer than this last one because we don't need the equation of the line in order to graph it, as long as we have a point and the slope. So I'm going to go ahead and set up our axes. All right, and then we want to put our tick marks on here. So we got 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Getting a little uneven, but that's okay. So for our slope for this one, before we start graphing this point here, our slope is negative 1/3. And so remember, this negative can go on the top or the bottom, but it doesn't have to go, or sorry, it can't go on both because a negative over a negative is a positive. So I'm going to show you both ways. If I put it on top, we have negative 1/3. And so this is saying go down 1 because it's negative and right 3. And a really common mistake here is putting, is going down and to the left. That would be a negative and a negative, which we don't want. Or you could put it as 1/3, which says to go up 1 to the left 3. And so these look like completely different things, but we'll graph it both ways and show you that they do end up on the same line. So to graph this one, we're going to plot our point first, even if it's not the y-intercept. So we're going to go to the right 2, down 3, and put our point right there. And now our slope tells us the first way to go down 1, right 3. So I'm going to go down 1 to the right 1, 2, 3, somewhere over there. If I were to plot it using the other one, I'll start at the point 2, -3 again. We're going to go up 1, left 3. So if I go up 1, left 1, 2, 3, as long as your graph is nicely set up, they should all be on the same line. They're just in a different direction. So it's perfectly fine to put the negative on the bottom or the top, but not on both. And then being able to identify what a line should look like with a positive versus negative slope. If we look back at number 2, we had a positive slope, so we were going up to the right. This one we have a negative slope, so we're going down to the right. So always double check your graph based on what type of slope you have. If we had a negative slope and we were going up to the right, there's some kind of problem there. We probably put the negative on both, which would give you a positive slope, so you'd be going the other way. So always double check that stuff. All right, now we have 2 more special cases. So numbers 4 and 5 here. Number 4, we're told that the line goes through -3, 3, and it has an undefined slope. So these are the ones where you're going to want to remember what kind of line you have with your special case slopes. Undefined slope means that we have no horizontal change because we're dividing by 0. And so we have a vertical line. And that's all we need to know. Once you know that, we can go ahead and start graphing. This one, let's go ahead and draw our axes. Just roughly. And we're going to plot our point at -3, 3. So left 1, 2, 3. I'll go out to 3 in all directions. So -3, 3. Here's our point, and we know it's a vertical line. So all we have to do is draw our vertical line through that point. And now if you wanted to add another point in there, you could, as long as it's somewhere along the vertical line. We can go ahead and do that. But if you know it's vertical, all you need is that one point, and you can draw lines straight up and down. Same thing with this last one here, number 5. We're told that it goes through 3, -2. And it has a slope of 0, or a 0 slope. So what we need to know here is that a 0 slope means that we have a 0 on top of our fraction here. So this means that our rise is 0, so there's no vertical change. No vertical change means that we have a horizontal line. Or you can just remember 0 slope means horizontal. However you want to do these, kind of reasoning through it or memorizing, that's perfectly fine. So let's draw our axes and put some tick marks on. I'll just go out to 3 or 4 in each direction. And so the point we're starting at is 3, -2, so write 3 down 2. And we know it's a horizontal line, so we don't need another point. If you wanted to put one anywhere on -2, you can. And then let's draw our line through those 2 points. Just want to make sure it's a horizontal line. All right, last part of this section is going to be on writing the equation of a line. And this part's usually a little bit trickier than graphing them. So writing the equation of a line. And we're going to do this based on some given information. We're not always given the same information, but we can always use y = mx plus b to find the equation of a line. So let's go ahead and look at some examples. We'll go ahead and start them here. So for these examples, we're told to find the equation of the line in slope-intercept form. So you want to make sure your final answer is in slope-intercept form. That's this y = mx plus b up here, using the given information. And so for number 1, we're given the y-intercept, 0, -4, and the slope, which is 1/2. And so this is the kind of easiest case for a question like this, because if you remember in our equation of a line, y = mx plus b, it has the slope and the y-intercept, which we're given both. So we can go ahead and just plug them straight in. And so we're always going to have a y and an x here. So y = m, which is 1/2 x plus b, which is -4. So I wrote plus, but I'm going to go ahead and erase that and put minus because it's negative. So we got -4 at the end. So this one, if you know you have a y-intercept and a slope, super easy, you just got to plug them in. Sometimes they're not going to explicitly tell you that it's the y-intercept. So if you can identify that it is, it's going to help you out. So what I mean by that is number 2, we're given the point 0, 8, and m = -1. So for this one, they don't explicitly say this is the y-intercept, but because the x-coordinate is 0, then we know that this has to be our y-intercept because that's the only place on the graph where we have an x-coordinate of 0. So we're given the y-intercept, we're given the slope, and we can go ahead and plug these in. So we get y = mx, so -1x, plus b, so plus 8. And if you want to kind of tidy this up a little, if you wrote this as y = -x, plus 8. That's a little bit nicer, but either one is perfectly fine. All right, let's try another one. This one's not quite as nice. This one we're given -1, 4, and m equals -2. So for one like this, we're still plugging in, but we're plugging in for different information because we're not given the y-intercept. So we can't just take this 4, put it in for the y-intercept and call it good. We're gonna have to plug in our point, and so this point here is our x and y. We're given our m, we're looking for b. We're looking for our y-intercept. So I'm going to go ahead and plug into y equals mx plus b. The big thing here is knowing what you're given and what you need to find out. We always need m and b regardless. We're given m, don't know what b is, so we have to find it by plugging this information in. So plugging in 4 for y, our m is -2 times x, which is -1, but we don't know what b is. So plus b, and that's what we're looking for. So I'm going to simplify and solve. So we get 4 equals +2 plus b, subtract 2, and we get 2 equals +b. Now we're not done. We have our b, and we have m. Now we can plug these in. We don't need this point here, this -1, 4 anymore. That was just to find b. Once we have b and m, we're going to plug it into y equals mx plus b. Y equals m, which is -2, x plus b, which is 2. So we plugged in 2 for the b, and we plugged in our -2 for the slope. All right, there's one other way that you could be asked this type of question. This one is based on a graph, and it's going to work really similarly to what we just did with the y-intercept and the slope. So let me go ahead and draw out the graph. All right, so this graph's a little big, but we're given the following line, and we're not told any information, so we're going to need to find our slope and y-intercept. We go through this point up here at 7, so 1, 2, 3, 4, 5, 6, 7. We're given that. We're also given that it goes through 2, 3. This is 3. And we're going to go all the way down to -9. So 1, 2, 3, 4, 6, 7, 8, 9. We're going to go through the point 3, 9. Make this look as nice as possible. You're going to see one like this on the homework, and it's going to be a lot easier to see where the points are. They're going to have a whole grid here, so you're going to easily see that this is the point 3, 9, or 3, -9. You'll be able to see that this is at 7. It's going to be a lot easier to see it on the homework. Now let me draw the line through these 2 points. So we have our line here, and what we want to do, if we think about how we found the equations before, if we had our slope and our y-intercept, it made it really easy. And so we can find both of those from a graph. We've done that before. The y-intercept is where it crosses the y-axis. So our y-intercept is the point 0, 7. And our slope is how fast this line is changing. So since it's going down, we know it's negative. Let's go ahead and find our vertical change and horizontal change. If you want to find the slope using the equation y2 minus y1 over x2 minus x1, you can totally do that, or you can just find it by looking at the graph. Whichever you're more comfortable with is perfectly fine. I'm going to do it by looking at the graph just to avoid any more work. So I'm going to start on the left side, and I'm going to see how far down we have to go. So going down, we go down 7 and 9 more. So 7 and 9 gives us 16. So we have to go down 16, so negative 16, and then to the right from 0 to 3, so 3. And so our slope is negative 16/3, kind of ugly, but we have our slope, we have our y-intercept. All we have to do is plug them in. Makes it really nice. Since we have the y-intercept, we don't need to pick a point for x and y and plug it in. We can go straight to plugging in our m and our b. So y equals mx, so negative 16/3 x, plus b, which is 7. So negative 16/3 x plus 7. Oh, and that's it for chapter 3. Next time we're going to start on chapter 4. Chapter 4 is solving systems of equations. So we're going to start looking at 2 equations with 2 unknowns, so x and a y. And then we're going to learn some different methods of solving those. But chapter 4 is just doing that same thing, just with different methods.